Alright, so here's how it started. Not terrible, but definitely not what I was aiming for.
It had a few issues. The biggest one was probably the assembly. Because the model is nearly a meter long, I had to split it into sections to print, and then join them together. I designed some locator blocks to help line everything up. But in the end, they just weren't that accurate. Another thing, the potentiometer setup was way too sensitive. If it weren't adjusted just right, the function wouldn't trigger at all. So for version 2, I went back and gave the whole thing a proper rethink. Let me show you what I changed. This is version 2, and it's a big step up from the first one. Assembly is way more accurate now, and a lot easier too. I've also added a flashlight feature, which is pretty cool. And I made a few tweaks to the code as well, just to smooth out how the whole system runs. These parts here on the table, that's everything that needs to be 3D printed. I went with a 0.2 layer hat, 2 wall lines, and 20% infill. Printed the whole thing in PETG. It's honestly my favorite filament at the moment. It's strong, prints well, and can handle a little bit of heat too. Compared to the last version, I've gone with much larger alignment blocks to help with assembly. All you need to do is slot the alignment piece into place first, and then apply a bit of super glue. That lines everything up nicely, and make the whole process way easier and more accurate. This part right here is probably the biggest change I made in this version. In the first build, I used a potentiometer with a 3D printed parts to limit its range. The idea was to hit specific values to switch between modes. It worked, but to be honest, it was a bit of a pain to adjust, way too fiddly. This time I went with 2 5.1 resistors and 4 round magnets, and redesigned the entire mode switch mechanism. Since the Halo 5 Assault Rifle has a safe, single shot, and semi-auto modes, I only need 3 distinct values to make it work. Now it's much more straightforward and way more reliable. As you turn the rotary switch, you will feel a little bit of resistance between each position. That tactical feedback helps you know exactly when you will switch the modes. It's got a nice clicky feel, so you are never second guessing where it's at. I also added a flashlight, and the power switch is tucked in right here. I'm using a limit switch with a small mechanical setup designed to trigger it. So, when you push or pull the lever, it presses the switch underneath to turn the light on and off. It's simple, clean, and works really well. For the sound, I went with a different speaker this time, one that fits much better inside the body of the model. I also designed a proper mounting bracket to hold it in place, which is a big upgrade from the hot glue I used back in version 1. Now let's talk a bit about the electronics. So far this version, I designed a custom breakout board. It helped tidy up all the wiring, and I added proper labels for each connection. That made a huge difference, not just in terms of looks, but also for usability. Everything's much cleaner now, and way easier to troubleshoot if something goes wrong. Next up, the display. In the previous version, I used the 1.9-inch LED display, but the breakout board it came with was huge. I had to really squeeze it in just to make it fit. For version 2, I designed my own custom breakout board, and it's way more compact. It fits into the model much more easily now. No need to jam things in. I also updated the housing for this section to reduce visible seams, so overall it looks a lot cleaner and more polished. So that pretty much covers all the main upgrades in version 2. Now let me take you through the full assembly of this Halo 5 Assault Rifle. I'll show you how everything comes together, step by step, and walk you through the whole process as we go. Alright, here's the first section, and this one's pretty straightforward. To make 3D printing easier and save a bit of filament, I split it into a few separate pieces. There's nothing too tricky here. Once you clean off the supports, all you need is some super glue to stick the parts together. No special tools required, just line them up and press them in place. Except for this one, you'll need to knock it in gently. Now, we are getting to the fun part, and probably the part that needs the most patience. In this section, we'll be fitting the ESP32 control module, the speaker, and the mode selector, and the flashlight power switch into the assault rifle. When you are removing the supports, take your time and don't force anything. Some of these are a bit delicate, so just work slowly and carefully. Once all the supports are cleared out, grab the second and third sections, apply some super glue, and join them together. It takes a few seconds to set, so just hold them in place until it grabs. We can move on to the actual install. The ESP32 control module goes right into this part here. First, we'll install the power switch, mount the bracket onto this piece. Then use two M310 screws to secure the ESP32 board to the bracket. I use a soldering iron to finish wiring the power connector. Once that's done, plug in the ESP32 module. After that, insert the entire assembly through this slot. Carefully tie the wire harness inside, guide the wires through, and then secure the module using one M313 and two M310 screws. Next is the motor selector. It's held in place with two M310 screws. Then we'll attach the rotary lever to the selector using one more M310 screw. Just be careful not to over-tighten it. You don't want to bind up the movement. You can also add a bit of grease to help it rotate more smoothly. Once it's in, give it a twist and feel that nice bit of feedback. At this point, we can connect the motor selector to the control module. Just find the connector, plug it in, and that's it. Grab the speaker and the mounting bracket. We'll start by screwing the speaker onto the bracket using two M310 screws. Then place the whole module inside the raffle, and then secure it with another two M310 screws. Once that's done, plug the speaker into the control module, and you are good to go. We'll install the flashlight switch into its slot. For this part, you will need 3 M310 screws. We also need some tools to help out here, like a pair of tweezers. Use the tweezers to carefully position the switch in place. Then grab a screw, pop it onto your Allen key, and gently feed it through this hole into the mounting point. Tighten it down slowly, and it might take a few tries to get it lined up just right. Once that first screw is in, repeat the same process for the second one. Now take the third screw and place it into the rotating piece. Use the tweezers again to get it into position, and then feed the rotary handle from the other side. Tighten the screw, but not all the way. You'll want to leave just enough resistance so that the switch kicks properly when you rotate it. Now for the final part, we'll install the trigger and its macro switch. Start by mounting the macro switch using two M310 screws right here. Then feed the trigger in place and secure it with one M320 screw. To give it some return force, we'll loop a rubber band over the back. That adds a bit of tension and gives the trigger a nice feel. Give it a press. If you hear a click, that means the macro switch is being triggered properly. And finally, we're back to here. Here we'll be using 6 round neodymium magnets, 10 mm in diameter and 2 mm thick. Just glue them into the designated spots. But make sure to double check the polarity before you stick them down. You want the cover to snap on properly, not push away. In this section, we'll be making a spring. You'll need a drill, and either an M6 bolt or a 6 mm steel rod around 5 cm long will do the trick. Clamp it into the drill, then take a piece of spring steel wire and start winding it around to form the spring. The spring should be about 3 cm long, and just make sure the out diameter stays under 7 mm. Let's take a look at the 3D printed parts. For the mag release mechanism, we'll need to sand the contact surface a bit to smooth them out, then apply a bit of grease to help everything move more freely. Slot the spring into this latch and feed it into the slot inside of the raffle. Hold it in place with your finger, then slide this top piece in to lock it down. From the opposite side, insert this part here and secure the whole thing with an M310 screw. Give the release button a press and check if the mechanism moves smoothly. This next part is a spacer, are separated from the main model to get a better print quality and more accurate alignment during assembly. It goes right into the mag well here. You might need a small hammer to tap it into the place, but I'll actually just use the handle of a file to knock it in. Make sure to watch this area closely as you tap it in. Don't go too hard or you might crack something. That's everything in this part. So we've now finished all 4 main sections. Now it's time to bring everything together. They are the alignment pieces. Apply some super glue to them, slot them into the matching joints, and hold them in place for a few seconds until the glue sets. Next, apply a bit more super glue to this section here. Before joining the parts, make sure to feed the flashlight cable from part 1 through this opening. Line everything up carefully, push it together and hold it firmly for a good 20 to 30 seconds while the glue sets. Once that's done, parts 1, 2, and 3 are now fully joined. Now, moving to the other end, apply some super glue to the alignment pieces and insert it into position. There are also 2 reinforcement pieces here. One is secured with a screw, and the other just needs a bit of super glue before you slot it into place. And now for the last big chunk, apply some super glue, line it up with its spots, and slide the whole section into place. Hold it firmly for a few seconds until the glue sets. Then secure it with one more M3/10 screw. The mag release switch still needs to be secured. Just pop it in here and use 2 M3/10 screws to hold it in place. Place this cover on and secure it with the screw. This one slides in from the back along its track, then pushes forward into position. Once it's in place, fasten it with a screw. The reason this cover is removable is to make further maintenance a lot easier. Finally, feed the stock and the last 2 small covers into place. Alright, that's pretty much the full assembly down. Let's just double check and make sure we didn't miss anything. Connect the power, slide the battery inside, and put the cover back on. Then secure it with one M5D screw. I almost forgot about the display unit. Find the connector and plug it in. Line up the feet, then push it into place. Before we call it down, it's time for a power test. Now let's check the modes. Single shot works. Semi-auto works. Safe mode, it's not shooting at all. Flashlight switch on and off, no problem. And the live compass looks spot on. Everything seems to be working perfectly. This build is a success. Alright, that's all for this one. If you enjoyed this build, feel free to leave a like and subscribe. It really helps the channel out. Let me know what you think about this build. Drop them in the comments. I'd love to hear from you. Thanks for watching, and I'll see you in the next one.